Hello Internet, welcome to another video on microprocessor. Today's video is continuation of the discussion of 8255A. In the previous tutorial we discussed the programmable peripheral interface and the configuration of ports. How do we set modes of the ports and so on. In today's tutorial we'll do the BSR mode. If you have been referencing my previous video, you know that if we put a 0 in the most significant bit of control word register of 8255, we get to the BSR mode. If we put a 1, we go to the IO mode, which has already been discussed in the previous video. Today let's talk about BSR mode. Let's start the discussion with the point that BSR mode is concerned only with the 8 bits of port C. Please understand, port C is the most versatile port of 8255. Its versatility lies in the fact that it can be used as a 2 4-bit ports, simple IO port, 4-bit C lower and C higher, and then again it can be used as handshake bits for port A and B. Now this function is very important. This function needs to be understood very clearly, that if we choose to select port A or B to be handshaked ports, then we need additional control bits to be transferred with the port data, and those additional control bits are assigned to port C. To be able to use port C as handshake bits or control bits or customizable bits kind of a thing, we need to have the ability to set or reset its individual bits by some means or the other, and that is what BSR mode provides us. So BSR mode will set or reset the bits of port C individually. And how does it do it? Let's see, which is pretty easy, because in BSR mode this is our control word. If we put a 0 in the most significant bit D7, we go to BSR mode, and let's say we have these 8 bits or 8 pins of port C starting from PC0 to PC7. If you wish to make the first bit PC0 of port C as 0 or 1, what we need to do is we need to select the bits from here, D1, D2, D3. These 3 bits are known as bit select combo. So a 0, 0, 0 will select bit 0, and a 0, 0, 1 will select bit 1. So you need to make the table 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So this is going to select bit 2, 3, 4, 5, 6, and 7. So selection of bit is done by D1, D2, D3. Once bit is selected, we simply need to make it as 0 or 1, and that can be accomplished by putting a 0 or a 1 in D0. So it is pretty simple. D4, D5, D6 are not being used. They are set to 0 always. To illustrate the functioning in a more appropriate way, I've taken up this example, programming example, where we need to write a BSR control word subroutine to set bits PC7 and PC3 and reset them after 10 milliseconds. We assume that the subroutine is also available, and the control word register is placed at 83H port number. We are using IO mapping, so 83H becomes the port number of control word register of 8255 from the point of view of 8085. So the first step here will be to see PC7. If you need to make PC7 as 1, so I'll write to set PC7. What should be the code? We need to go to BSR mode, then these are zeros all the time, and we need to go to PC7. 7 is this one, so we put a 111 here, and we need to set it, so I'll put a 1 again. So this becomes the code of setting PC7 or putting a 1 into PC7, so it becomes 0FH. And to reset it, to reset this bit, this one, I'm making it as a 0. What I need to do is I need to make this 0 0 0 0. I need to go to the same bit, but I make it as 0, so this becomes 0EH. And similarly, to find out a PC3, for PC3, what I need to do is I'll need to select the bit 3, which will be selected as 011, and making it 1 will require me to use it as 1, and so code becomes 07H. And this is to set it, and to reset it we need to use 0 0 0 0. I go to 3 and making it as 0, so it becomes 06H. So this is what it is, simple as that. And the programming is even simpler. What I'll do is I'll make PC7 as 1, I'll make PC3 as 1, and then I'll call delay, and then I'll make PC7 as 0, I'll make PC3 as 0. And I need to accomplish this with the help of IO mapping, so I can only use out command or in command to send the data to control word register. Now sending 0F into control word would automatically make PC7 as 1. You need to appreciate the fact that we simply need to calculate the code and send it to the control word register to set or reset the bit. Now once we are able to send these calculated bytes to control word register, the corresponding C bit will be set or reset. And now it's pretty simple. So what I'll do is I'll immediately move into A0FH, and then I'll out it to 83H. So this is what I'm doing is I'm putting the code to set PC7 into A, and then I'm sending the data of A to control word register using out command. Why I'm using out command? Because 83 is the port number of control word register, and to send to some port from 8085 we need out command. And similarly what I'll do is I'll move into accumulator the code of making PC3 as 1, and then I'll use out 83H, simple, and then I'll call the delay, and then I'll move into accumulator the code for making PC7 as 0, and then I'll send it to control word register. I'll move the code of making PC3 as 0, I'll send it to accumulator, to control word register, and then I'll return. And now this we need to write a subroutine, so I'll write down the program and I'll end it with a return instruction. So in this tutorial I've used the concept of IO mapping because control word register is placed at 83H port number with respect to the microprocessor. So if you need more help on IO mapping versus memory mapping, you can check out my video which I've already uploaded on the playlist. And the second concept that I'm using is the usage of return in the subroutine, so you can check out my video on subroutines and returns and advanced subroutine concepts in the same playlist. And I hope this quick tutorial on 8255A BSR mode was of some help, and if it did, please consider subscribing to the channel. You have a very good day ahead. Bye.